Hello, friends. Today I'm going to give a small talk about drilling data analytics. Uh, the TIPCO Spotfire, is a data analytics software, and its usage is extended to drilling data. So here is an Excel file, very a small Excel file, a daily time ASCII file with a very few details such as date, time, bit depth, total depth, TBD, and flow pumps. Okay, so this is the data, and here is the TIPCO's spot file. I have opened uh, a file saved in a spot file, which is named as a demo drilling data analytics.dxp. .dxp is the extension. Whatever file you load in the spot file after the exercise, what you want to achieve is done, when you save the file, it saves as a .dxp file. Okay, here is the graphics visualization of same Excel file loaded in Spotfire, and it's visualized with the time on the x-axis, bit depth, total depth, TBD on the y-axis. So one can see that the TBD and total depth both are almost matching. And moreover, it is safe to assume that the trend of this TBD, total depth, bit depth, is almost in a straight line, so linearly trending upward in a very steady fashion, which indicates that the ROP is almost uniform, which is possible and likely for controlled drilling. If it is not controlled drilling, maybe it is a very hard formation, which is allowing only limited rate of penetration. Well, let us assume the worst case, very hard formation with a limited ROP. And you can see that the bit depth is not constant. It is going up and down, which is indicative of too much reciprocation during drilling. So it's very safe to assume that the driller is finding it very hard to drill through. Either it is a controlled drilling or it is a very hard formation. Whichever be the case, the um, the reciprocation is the factor that is not very well planned for. And the next, I want to show you my data. Data is here. In the Excel file, I showed you the date, time, bit depth, total depth, TBD, and flow pumps. In addition to those data, I have added some other columns. The 7 columns I added: time span, drilling time, cumulative drilling time, off bottom circulation, cumulative off bottom circulation, pump out, cumulative pump out time. Okay, so this um, additional columns are added using DAX functionality. DAX functionality allows one to create new columns based on certain formulas. Whichever formula he want to apply, he can apply the formula and create a new column. It's a new measure basically. So how does one do that? So it's basically yeah. So it's a very simple thing. So this is one example of the tax functionality. It says if bit depth is not equal to total depth. And the other condition is if flow pumps greater than 1, then what you get? You get time span, which is the difference in time. And it records the difference in time only when these two conditions are meeting. And these two conditions are valid for off-bottom circulation. So this is an example of DAX functionality. Okay, I don't want to do that. It's already done. So I'll just skip that. So I want to go to the graphics. And the next page, I can show you the flow pumps. Okay, there are three connections where flow pumps is 0 here. Okay, so basically one can see that we started from 802 and ended at 872. Yeah, okay. Yeah. I'll get a better view about this. This is the 802 and here is 872. So 70 meters for entire 24 hours and only three connections. So this is a very low score for drilling engineer's plan. So obviously he would want more progress to be made. Uh, as one can see in the first figure, it's very clear that reciprocation is the thief here. It has stolen a lot of time. So better visualization will be with this. So here on the left side is the yellow bar, and this is the red bar, and this is the blue bar. Yellow bar is indicative of cumulative drilling time, which is 10.24, 10 hours 24 minutes, and the red bar is cumulative of bottom circulation, and blue bar is cumulative pump up time. So obviously pump up time is better explained in terms of connection. So one has to switch off the pumps for connection. So three connections took 10 minutes, and 70 meters took uh, 13 hours 25 minutes circulation plus 10 hours 24 minutes pure drilling time. This pure drilling time is considered as the productive time, and this is the bottom circulation time and pump up time both are considered as flat time. So better ways to manage this time in order to improve the productive time is to plan the well accordingly. So what are the major causes for this extra cumulative bottom circulation time? We really can't say much because the details I have here available is very limited, and with that only certain assumptions can be made. The one assumption is that the reciprocation is due to very hard formation, not letting that big to drill through. And the other one is some kind of controlled drilling in order to achieve certain objectives, which is not available with us. The details about that objective is not available. So, all in all, we can say that this cumulative off bottom circulation time must be reduced in order to improve the performance and efficiency. So, theoretically, it would be ideal to classify 30 to 40% of this red bar as ILT or invisible lost time, maybe due to wrong practices, unplanned events, unplanned obstacles in the drilling scenario. All these are part of the, or maybe the bit is not the suitable one for this current formation. So all this could be categorized as ILT. Um, so maybe from this figure, one can uh, make a lessons learned event and accordingly plan the next well in order to minimize the ILT and improve the share of cumulative drilling time in this figure. Usually, one would like to have cumulative drilling time dominates in the bar chart. So, thank you for watching. Uh, One thing more, in Spotfire, basically ETL, extract, transform, and load. Extract is extract data from the data source, and transform is preliminary data checking for formats, missing value, null value, duplicates, etc., etc., and correcting the data for those discrepancies or shortcomings, and then making new calculations uh, for new columns, and finally loading the software, loading the data into the Spotfire. The other method is ELT, extract, load, and transform. One can extract the data, load it directly, and then visualize. And then, after visualizing, see what is needed and subject the data into transformation. Basically, transformation would involve creating new columns or new data based on certain formulas about which only the user can have an idea about. Okay, so this is one way of loading the data into the software. So extract, transform, and load. Extract, load, and transform. These two methods are optional. These two methods are available, and that is being widely used uh, in the software analysis. Thank you for watching.